anyone that didn't get their exam back last name. So the final, the black portion of the final is Friday, December 16th at 8 a.m. So it's not our regularly scheduled time. 10 o'clock, there won't be anyone here. So be careful of that. I do have a final on Wednesday at 10:30, so if you would like to take it earlier than Friday, and I'll let you know where it's at. Anyone who hasn't gotten their exams back. Your last name? So the project was due on Sunday and at least 5 responses by this Sunday. Covered the outlines for chapter 12 and 13 last class. So today we have probably covered most of the homework for 12 and 13. So there's 2 homeworks in here. I didn't throw them together. I just left them separate so you know which came from what section. There's also a lot of videos here. If you need help. Everyone see it okay, or you want the light on? You can bring it up on here. Part 4, determine whether the scenario involves independent or dependent events. Circle the correct one and explain why. Or you can just write it and explain why. Remember, independent means that one probability doesn't change the next one, where dependent changes it because it depends on what happened first. If you look at the first one, you flip a coin and then roll a fair six-sided die. Independent or dependent? Independent. It's independent because when you flip the coin, it's not going to affect the probabilities of rolling the die. The two have nothing to do with each other. One will not change the outcome of the other. So they're independent. And make sure you write a sentence explaining the one probability doesn't change the other. A box of chocolates contains 5 milk chocolate and 5 dark chocolate and 5 white chocolate. You randomly select and eat 3 chocolates. The first piece is milk chocolate, the second is dark, and the third is white. Would these events be independent or dependent? They're dependent because when I pull the first one, what did I say? The first one, milk. There's 5 milk out of 15. But then I don't put it back in, so now there's not 15 in there. It's changing the probability because there's only 14. So they're dependent because the next event depends on what the first one chose. The probabilities have changed. Any questions so far? Don't forget to write a sentence. A bag contains 8 red marbles and 4 blue marbles. You randomly pick a marble and then pick a second marble without returning the marble to the bag. First is red, second is blue. Independent or dependent? Dependent, because I'm not putting that marble back. Now I've changed the probabilities because there's not as many in there. So to start with, the second marble was blue. To start with, it was 4 out of the 12. But when I pulled out, hopefully a red one, and I didn't replace it, now there's less marbles. It's not the same probability as it would have been. So it's dependent. Make sure you write some. Any questions? So. A cooler contains 10 bottles of sports drink, 4 lemon lime, 3 orange, 3 fruit punch. 3 times you randomly grab a bottle, return the bottle to the cooler, and mix them up. The first one is lemon lime, second and third are both fruit punch. Independent or dependent? Independent. Because I'm putting it back in, then my probabilities stay the same. I'm not changing the probabilities. So because of replacement, they're independent. And make sure you write that. Any questions on that? So the first one was independent. Oh, those two had nothing to do with each other. Any questions on the difference between dependent and independent? You'll definitely see it on the slide. You flip a coin and then roll a fair 6-sided die. Independent or dependent? Well, we kind of answered this one already. It was the first question. No, thank you for, anytime you have a blank, just fill it in. But the last one, you would also show your work. Find the probability of pulling heads up and dashes. I remember doing that when I did these videos. I was doing them. I did do it. Don't remember that question. Okay, yes, so if there's a blank, just fill in the blank. If there's not, you should use a sentence. How many outcomes are there?
Well,
Remember, because these are independent, we can just multiply the outcomes for each. So to flip a coin, heads or tails, that's 2. And then a fair die has 6, which gives us 12 plus blocks. Okay, list just one of them. What's one? Anyone?
tails and 2.
Tail and a 2. So an H or a T, and then any number 1 for 6. And you can even write it out, heads and 1, but you can abbreviate it, H or T, and then any number. So the toss of the coin, the roll of the die, put them together. And if you had to write all of them, there should be 12. Find the probability that the coin lands heads up and the die shows a 3. Now there's a couple ways you could do it. One way is to list all 12 outcomes in order to show it. If you're going to go by the outcomes, you have to list all of them and show how many have a heads and a 3. How many do have heads and a 3? One of them, 1 out of the 12. So we could have 1. And the tails. And there's only one of them out of the 6. So the probability of a head and 3. Sorry, I said 6, but it's 12. Another way of doing it, the probability of the heads is 1/2. And the probability of a 3 is 1/6. Because they're independent, you can find each probability separately and multiply them together. So the probability of a heads is 1/2. The probability of rolling a 3 is 1/6. When you multiply those, you get 1/12. Either way is fine. The only thing is, if I give you one that has 36 outcomes, I don't think you want to write them all down. So it's good to know the other version. Any questions on that part? Either one is correct, as long as you show me how you found it. So this one doesn't have to have a sentence, you just have to show work. You roll a fair 6-sided die twice. Independent or dependent? You say independent. Independent. Because when I roll the first dice or the same die, whatever I get on it is not going to change the second one. So rolling 2 die, they're each independent. How many outcomes are there? Think of how many there are when you roll the first one. How many there are when you roll the second one. Multiply it together and you get 36. What could be one of the possible outcomes? A 1 and a 4. A 1 and a 1, a 6 and a 6. Any number 1 through 6 paired with any number 1 through 6. 2 7s would not be right on a 6-sided die. But you could have a 1 and a 4. Any questions on that? What is the probability the first roll shows up 5 and the second is an even? Well, we could list them all.
Why, it's the first one. It's 1 out of 6. Second one is 1 out of 3.
Okay, yep, you could do that. So the first one is 1 6 because there's 1 5 out of the 6. And then the second one you could do half instead of third. Half of them are even and half of them are odd. So you could do half of them are even, 1 half, or you could do 2 4 and 6, 3 6. So you could have done 3 6 or half of them are even. Those are both the same answers. Because if I take the 336 and divide top and bottom by 3, I get 112. Either way is fine.
Do you want us to simplify it?
If you did it this way, I would not simplify. But having it simplified is okay. I like to leave them in this version. If I want to add some together, I already have the same denominator. But another thing that's nice about having it in this first version is the denominators match, so I know I probably did something. But reducing is fine. Just don't make a mistake. Or show your work so I know that's what you did. Any questions on that one? There are 8 shirts in your closet, 5 blue, 3 green. You randomly selected them to wear on Monday and then a different one on Tuesday. So we are assuming you're not putting the dirty one back in the closet. Independent or dependent if you're not putting the dirty shirt back? Because since I'm not putting it back, whichever one I wore is not in there anymore, it's changing probabilities. Because there's less shirts, you're dividing by a different value. The second one on Tuesday depends on what you wore on Monday. Any questions on that? How many outcomes are there? Even though they're 4. Even though they're not independent, we still could look at it. When we pull the first shirt out, there's 8 shirts in there. So there's 8 different possibilities, even though they're different, some of them are the same color, it's still a different shirt. So when I go to pull it out, I have 8 to choose from. Now I'm not putting it back in, so now I have the next day 7 to choose from. So even though they repeat, you still want to count all of them. So there's 56 outcomes. So even though they were independent, I still could think about the number of outcomes. I just needed to be careful. Any questions on that part? To list one of the outcomes could be blue and blue, green and green, blue and green, green and blue. But one, well, 2, they could repeat. So for your outcomes, you could have 2 blue, a blue and a green and then a blue, or 2. So any of those would be a possible outcome. Oh, I see why you're saying 4 now. On this one, I was thinking of all the different possibilities with every shirt being different. Here, I was just thinking of what letters you could have. I have to remember that when I grade. What is the probability wear a blue shirt both days? So if we're going to wear a blue shirt both days, what's the probability the first shirt is blue? 5 out of 8. Now, if it is blue, now we only have 4 blue, 3 green, 7 shirts. And that's why when we multiply the number of outcomes, we multiplied 8 and 7 together. If we want to pull another blue shirt, now this is what's in our closet. What's the probability of pulling a blue one? The 4 out of the 7? Any questions on that? Now, this is a case where you want to write all of the different possibilities. Any questions on that? Another thing you probably could use on this one, I don't know, it might be a lot of work. If you could do the first and then go blue, there's 7 blue. And then put all 7 of them. And then put the 3 green. And then from there you would go again. Oh, that would be a lot. I was thinking we'd only have to go 1 more, but then off of each of those it would be 7. There'd be 4 blue and 3 green. I don't think a tree diagram. But it helps you see how many there really are. Any questions on that one? A basket contains 6 red apple and 7 peach. You randomly select 1 piece of fruit and eat it. Then you randomly select another piece of fruit. The first piece is an apple, the second is a peach. Is it independent or dependent? Because I'm eating the piece of fruit, I'm not putting it back, it's changing the outcomes for the second one. So it's dependent. How many outcomes are there? First one, 13. But then we don't put whatever fruit we pick back, so then there's only 12, which I think was 156. So there's 156 outcomes. A lot of them repeat, but there's 156. What is one outcome? 2 peaches. Could have had an apple and a peach, 2 apples, but we're picking 2, so you would only have 2. So we're picking an apple and then a peach. You have 6 apple, 7 peach, total 13. When we pick the first one, what's the probability it's an apple? Anyone? Say it. I can't hear it. That would be 6 out of 13. Yeah, because that's a 13, it won't reduce. And my pets. No, once we pick that apple, there's only 5 apple and 12 total. So what's the probability that we pull out a peach? 7 out of the 12. 42 out of 100. Don't have to redo it. So the reason it was dependent, you can see how you're changing your values, so it's changing what this would have been. If I put it back in, that would be different. Any questions on those? Oh, a lot of people forgot about last week's homework. Half the class didn't turn it in. So, and that's fine. I mean, it was a holiday. And we didn't get to go over it in class. So chapter 13. The first one. So what this is it's a table I found, I think it was online or in your book, but speeding violations in the last year and no speeding violations. So they, I think it was a survey, whether you had a speeding violation or you didn't. Going across is if they use the cell phone or do not use the cell phone while driving. Total people in the survey, 755. The first probability, the driver is a cell phone user. They're talking about the driver, so they're using the total. The only time you need to be careful is on these ones where it says a given amount, that changes what you're dividing by. But in this case, it's just the driver, so it's all 755. And it says they use a cell phone. Well, the top row is using a cell phone. So if we go to the total, then there's 305 that use a cell phone out of the 755. Any questions? Now you can leave it in a fraction, decimal, percent. Or reduce. Unless it specifies. Sometimes I will specify to leave it as a fraction. Probability the driver had no violations. So look at how many people had no violations. And since it's the driver, it's the total. No violations, no violations. So this one is the total for no violations. 685 out of the 755. Any questions on that? Go ahead and try the next. So probability they had no violations and they used their cell phone. So how many people have no violations but use their cell phone? No violations is this column. Use their phone. Do you have 280 out of the 755? So, and just where the two overlap, or you need to be careful of. Any questions with, C? Is that what everyone got? Where they overlap divided by the total. Now if we look at use the cell phone, that's this top one going across 305, use the cell phone. Or no violation is here, 685. But notice when I go across and then when I go down, I'm using this 280 twice. I've added it in twice. So when you have an or and they overlap, you can add both probabilities together. But then you have to subtract their overlap. Because if we go across, or they use a cell phone, but then go down here, we're covering this 280 twice, so it needs subtracted out. So for this one, we could take use phone was 305 plus no violation 685. Then subtract our overlap of 280. Seven, 10. So you need to be careful with ors on a contingency table. Any questions on that? Now, the last two have a part that was given. If something is given, only use that row or that column. So in this one, probability, use a phone given yes to a violation. So given part is the violation. Yes, they had speeding violation. And use a phone, that would be 25 out of the 70. So when a part is given, only use that row or that column. In this case, the given was yes to violation. This one was the speeding violations. And then use a phone, 25 out of 70. So it changes the probability because we know a little bit more information. We know they definitely had a violation. So we only use that part. So now I'll double check that you did this one. So given there's no phone, so we only use the row where they don't use a phone. And then find the probability they also didn't have a violation. So no phone is the second row. Here. We're only using that row. Probability of no violation. So this one had a violation, these did not. 405 out of the 450. Any questions on that? The teen at a fancy private school is very worried. She suspects that 20% of the 1,000 students on campus find my numbers later, are using drugs. She's asked all the parents to administer a home drug test to their kids. Since it's a private school, she can't require them to do it. She has read on the web that with home drug testing methods believed to produce reliable, accurate results, many of us overlook the cases of false positives and draw conclusions on the suspect before confirming the results. But researchers from Boston University have found that drug tests may produce false positives in 10% of the cases and false negatives in 15%. Build a contingency table of the drug screening scenario. Now, what you have to remember is where your false positives and false negatives and true positives are. You always want to set up your table so the test goes across. So this would be testing positive that you use drugs. This one would, the test says negative. Going down is whether they use drugs or not. So across is the test. Down is whether the student does or does not use it. Looking at the first part, you can get this bottom row. We know she suspects, it says, she's assuming 20% of the students use drugs. So in the bottom row, we know there was 1,000 students. We know that 20% use drugs. What's 20% of 1,000? Remember, you write your percent as a decimal. Of means multiply. So 20% of 1,000, 200. Probably want to put in here like how you found it. Don't want to let me draw it there. But that way, then when you're looking back at your notes, you know where things came from. So of the 1,200 use drugs, how many don't use drugs? Because these two need to add up to this. So we take 1,000 minus the 200, 800. Any questions on that part? Now, on the table, these are both positives. For your true positive, true negative, this is positive, and this is positive. Because that's what the test said. The bottom is your two negatives. If you tested positive and you used drugs, the test was right. That's a true positive. So if you forget where they go, you can figure them out. This is positive. These are the two positives. This one was correct. You use it. This one said you use drugs, but you don't. So this was a false positive. These two are both negative because that's what the test said. If we look here, you tested negative, but you used drugs. So this was wrong. That's a false negative. This one you tested negative, you don't use drugs, it was correct. That's a true negative. As long as your test goes across, these will always be in the same spot. So if you want to memorize them, you can. But if you forget, you can figure it out. Any questions on where these are? And the first one is false positive. There's a false positive in 10% of the cases. False positive is here. Now, when we find this rate, we're using the value below it, not the total. So if this was 10%, it's out of the value below it. It's 10% of the ones that don't use drugs. So when you're finding your rates, you're using the totals here, not the whole total. So when you're finding your rates, you're using these values below. So then if you're given the rate, you use the value below to find out how many. False negative is here. 15%. Of the total in that column. So 15% of the 200. $30. Questions overall. Now the other values, if this is 30, we know adding down it has to equal to 200. So we just take 200 minus 30 and get 170. This one here. You know, adding down, we need to get 800, 800 minus 80, 720. And just add across. $720 and $37.50, and then add these two together to make sure you get the 1,000, just to check your values. Any questions on that? How many students are drug users? Here is the column for using drugs. 200. How many of the drug users tested positive? 70. So of the 200 students that used drugs, 170 tested positive, 30 tested negative. Any questions on that part? Now these are givens, like this first part here. That's what's given. A student tested positive for drugs. We know they tested positive. So that goes across this row. What's the probability they did use drugs? That's our true positive. Or no, it's not, because you use the bottom. But it would be 170 out of the 250 because we know they tested positive. 170 actually used drugs out of the 250 that tested positive. This one, if a student tested negative, so that's the given part. What is the probability he is drug-free? So tested negative is this row. Drug-free. 720 out of the 750. Any questions on that? So you have to be careful when some parts are given. You have to write a sentence or two. How you would feel if you were in the false positive group. False positive means you tested positive, but you don't use drugs. And false negative means, you tested negative, but you used drugs. So go ahead, and we can talk about the next class and then try this one and we'll work on it next class.